Welcome back to our mathematics series for WAEC, JAMB, and NECO preparation. Today we're diving into one of the most important geometry topics, circles. A circle is a set of all points in a plane that are equidistant from a fixed point called the center. The distance from the center to any point on the circle is the radius, and twice the radius gives the diameter. Circles appear everywhere in wheels, clocks, coins, and even orbits. In exams, this topic tests your understanding of angles, theorems, cyclic quadrilaterals, tangents, and mensuration. Mastering circles can give you a strong boost in Euclidean geometry marks across all three exams. Let's start with the basics. The circumference of a circle is 2 pi r, or pi d. The area is pi r squared. Use pi equals to 3.142 or 22/7 in exams. Now for arcs and sectors. A sector is a pi-sliced portion of the circle, bounded by two radii and an arc. The arc length is L equals to theta over 360 times 2 pi r, and the sector area is A equals to theta over 360 times pi r squared. Now to the powerful part, circle theorems. These theorems show relationships between angles and lines in a circle and are heavily tested in WAEC, JAMB, and NECO. Theorem number 1. Angle at center equals 2 times angle at circumference. So if arc AB subtends an angle of 80 degrees at the center, then it subtends 40 degrees at the circumference. Theorem number 2. Angles in the same segment are equal. Theorem number 3. Opposite angles in a cyclic quadrilateral sum to 180 degrees. Theorem number 4. Tangent chord angle equals angle in alternate segments. So if tangent touches point P and chord PQ is drawn, then angle between tangent and PQ equals the angle in the opposite segment. Theorem number 5. Intersecting chords theorem. If two chords AB and CD intersect at E, then AE times EB equals CE times DE. Now, mensuration deals with lengths, areas, and perimeters. A segment is the region between a chord and an arc. Its area is segment area equal to sector area minus the triangular area. But in radians, you can use another formula, which is half of r squared in bracket theta minus sine theta. Exam tip: always label your diagrams accurately because angle labeling earns marks in your WAEC exams. Let's take some worked examples. WAEC question number 1, 1989. A sector of a circle of diameter 8 centimeters has an angle of 135 degrees. Find its area. Take pi equals to 22/7. Now the radius of the circle is 4 centimeters because the diameter is 8. So my area is then 135/360 times 22/7 times r squared, which is 4 squared. So 135/360 is 3/8. So your area is now 3/8 times 22/7 times 16, which is equal to 18/6/7 centimeters squared. Now, in 2004, a tangent KS touches a circle at R. If angle ROQ is 80 degrees, find angle QRS. Now, angle ROQ is an angle at the center. What is the angle at the circumference? If it's 2 times the angle at the circumference is 80 degrees divided by 2, which is 40 degrees. So by the alternate segment theorem, angle QRS is also 40 degrees. Now this question was asked in 2020. If angle OPQ is 48 degrees, find the corresponding angle at the circumference M. Since angle OPQ is at the center, the angle at the circumference is 48 degrees divided by 2, which is 24 degrees. Now, let's go to JAMB questions. In 2010, an arc subtends an angle of 50 degrees at the center of a circle of radius 6 centimeters. Find the sector area. Formula for sector area: A equals to theta over 360 times pi r squared. So your area is 50 over 360 times pi times 6 squared, which is equal to 110 divided by 7 centimeters squared. Now for the NECO questions. In 2008, a sector of angle 120 degrees is cut from a circle of radius 13.5 centimeters. Find the area remaining. The full area of the circle is pi r squared, which is 572.8 centimeters squared. The sector area is 190.9 centimeters squared. So the area remaining is the total area, which is 572.8 centimeters squared, minus the sector area, which is 190.9 centimeters squared. And that gives us an area of 381.9 centimeters squared. Now in another NECO question, the two chords intersect. Point AP is 3 centimeters, point PB is 5 centimeters, and point CP is 4 centimeters. Find PD. Now we know that AP times PB equals CP times PD. So AP times PB is 3 times 5 equals 4 times PD. And that gives us that PD is 15 over 4, which means that PD is 3.75 centimeters. Now in 2023, if a central angle is 100 degrees, find the angle at the circumference. The angle at the circumference is the central angle divided by 2. So our angle at the circumference is 100 degrees divided by 2, which gives us 50 degrees. Now let's summarize. The area equals to pi r squared. The sector is theta over 360 pi r squared. The central and circumference angles are related by the formula center equals to 2 times the circumference. In the cyclic quadrilateral, the opposite angles are always equal to 180 degrees. And for intersecting chords, product of AP times PB equals product of CP times PD. So to recap, central angle is twice the circumference angle. Tangent is perpendicular to radius. Opposite angles in cyclic quadrilaterals are equal to 180 degrees. And intersecting chords multiply to equal products. And sector and segment areas come from pi and theta relationships. Now your exam strategy should be that in JAMB, use quick angle identification. But in WIAC and NECO, show every step and diagrams clearly. Use pi equals to 22 over 7 unless otherwise stated. Memory tricks for you to help you remember would be center twice circumference for angles and tangent alternate for tangent chord theorem. That's it for circles in mathematics. Keep practicing past questions and join us for the next lesson on mensuration. Learn smart, pass confidently.